Now we're going to move and start talking about advanced ciphers. And what I want to focus on for this section is asymmetric ciphers and just cover the concept of where they're used and why they're chosen in certain areas. Why don't those symmetric ciphers scale? Why do we need asymmetric and why don't we just stick with the symmetric ciphers? Well, let's take, for example, two people who have not spoken before. You don't have the concept of a shared key, which is needed for symmetric, so there isn't that symmetry there. Similarly, if those two people, even if they have talked before, how do they communicate using a message to demonstrate which of them wrote it and which of them is intended to receive it? So if you use asymmetry, where there's a different thing used at creation or encryption and decryption, then you can enable cryptography at a little better scale. How does this work? Each party in this organization has a public key and a private key in asymmetric cryptography. The person on the left, let's call her Alice, and the person on the right, let's call him Bob. She uses his public key, which she gets, and combines it with her own private key in order to create encrypted data. So because it uses his public key, we know it's for him, and because it uses her private key, we know that it's from her, and it can't be read by someone without the corresponding version of her public key and his private key. So it's this combination of keys that lead to the cipher going one way. So essentially, once she writes it, she can't decrypt it again. I use the examples Alice and Bob here. Almost all cryptography examples use the names Alice, which is A, and Bob and Charlie, so Bob being B and Charlie being C. And there's another funny cartoon here where if you just want to keep a cryptographer busy for a while, you just start telling them a pretty boring story that involves someone named Alice and Bob, and you just kind of have it going nowhere, but you keep coming up with something for all of them to do, and you'll get somebody to pay attention for a while they start waiting for the cryptographic story to kick in, even though you don't really have one. So why should I use an asymmetric algorithm? Well, if you're communicating with a sensitive partner, what happens here is that you don't have a shared key. So the lack of the shared key means that you don't have to have that exchange wherein anyone with the individual key can both encrypt and decrypt. Now, another time is if you're encrypting and working with anything that is not directly under your exclusive control. For example, you have to give it to a third party or you have to integrate with some other person. You might want them to have their public and private key combination as well, just so that you don't have to have that trust of a shared secret, which is required for symmetric control. Asymmetric is slow. Why does it feel fast? It is true symmetric ciphers are a little bit faster than asymmetric, actually quite a bit faster. So what happens is a lot of systems will use asymmetric in order to do a key exchange, and then the first thing that they'll exchange and transfer between each others is a unique symmetric key that they'll use to speed everything up from that time forward. And if you don't do this and you go and you constantly do asymmetric over and over, things will get very slow. But that's fine because that's the way that most people do it. What are some popular asymmetric algorithms? By far and away, the most popular one is RSA, not to be confused with the security company RSA, even though their founders are the ones who invented it, and that's why it has that name. It is an algorithm. It's just the most popular one that's used. Another one that's relatively popular, but not as much, is elliptical curve, followed by Diffie-Hellman, which is also quite popular. What are the most common asymmetric systems? Well, HTTPS uses asymmetric cryptography all over the place because that is a browser and a different server communicating. And you think about that, how could you have a secret key go between one person and all the websites or all the various advertising networks that shove ads onto their client? You couldn't have symmetric cryptography operate at that scale, so it has to be asymmetric. It also is heavily based on the concept of certificates, which we'll get to in a little bit, and they can use something called a key signing request so that they can keep that private key secret from the cloud providers or the certificate authority and get certificates, which we'll cover in a later on section. Certain cloud providers, though, if you do your certificate signing request in the cloud provider, then they technically have access to the secret key as well.